we don't really like the number 3.2 over 30 because it's like a fraction and also a decimal. We always want numbers to be either a fraction or a decimal. So luckily you have a calculator now. Put 3.2 divided by 30 in your calculator. So we get this decimal. We notice that it's not a terminating decimal, so it's repeating. It goes on forever. That's what tells me I shouldn't use a decimal here because the only way to write it down would be to round it. Because this is repeating, you could put that bar over it, but you can't do calculations with 0.6 with a bar over it, right? That's not something you can plug into your calculator. So we want a number we can actually perform calculations with. So once you do that division, hit the math button. And notice that at the very top, it has an arrow and it says frac. So if you hit enter and then enter one more time, it will simplify that fraction for you so that you don't have to go through that whole process. And what do you get?
8 over 75.
Yeah, good. So C is equal to 8 over 75 times X. So you can totally use that button anytime you want. I don't need to see all your fraction calculations. It's pretty handy. Does it make sense how we got that formula? Good. So let's use that model to find the cost of driving Christy's car 500 miles. So just like we did yesterday, we're relating C and X, which means they have to give me one if I want to find the other one. So we are finding a cost. So I want to find C, which means they have to give me X, which is what that 500 miles is. So we have C equals 8 over 75 times 500, which is, oh, that's a 3. This is, oh. 240? No. What's the numerator? What is it? 60? 160. Thank you. Oh, yeah, because it was 20. Yes. So this is like my final answer, but just like we talked about yesterday, when I write that sentence, we want it to be like realistic in terms of the problem, right? Nobody's like, the cost of driving the car 500 miles is 160 thirds dollars, right? We don't talk like that. So at this point, it's totally appropriate to get a decimal and then round it to 2 digits, so it's in dollars and cents. So the cost is what? 53.3, and we want to go 2 digits, so it's in dollars and cents, right? So rounding to the nearest cent is 2 decimal places. Is that what everybody else got? I just trusted Kenny there. Yeah? Questions? So far, so yeah?
Is it okay if originally we come up with a different equation for it, but it still works out?
What? So tell me about your equation.
I've done x divided by 30 in parentheses times 3.20 and still got the same answer.
Oh yeah, that is the same equation.
Okay.
It just looks different. So you're multiplying by 3.2 and dividing by 30, which is exactly what we're doing there.
Okay.
So yeah, that's fine.
Differently.
Yep, totally fine. Okay, let's find the number of miles that she can drive. Oh, there's a typo. Pretend that's not there. Each month without exceeding her monthly gas budget. You guys try that one. So we're going to talk about percents. We want to use the same basic 4 steps for these problems. The nice thing about percents is that you'll always use the same equation. So you don't have to think about like if you're adding or subtracting or multiplying or dividing and how they're related, you're always going to use the same equation. So the basic percent equation is amount equals percent times base. And we usually abbreviate all that as A equals P times B. And the key to figuring out which numbers go where is that the percent and the amount always represent the same quantity. So the percent represents the quantity as a ratio. So if I say 90% of students pass Math 121, it doesn't tell you how many students pass 121. It just gives you a ratio, right? That 90 out of 100 always pass it. So it's a ratio rather than a set number of people. So, but it's representing the people that passed. And in this case, the amount represents that same quantity as a number of whatever you're measuring. People, dollars, miles, etc. So your units will just depend on the individual problem, but the percent is a ratio. The amount is you're actually counting how many of something that ratio represents. So when we set these problems up, this like step one in our 4-step process is going to be always basically the same. We write our A, our P, and our B. And then we always want to label first. So the words, just like we talked about yesterday, are probably the most important part so that we have written down exactly what each thing is and what each variable represents. So in this case, what does that 20% represent? It's the percent. So when I said like 90% of people pass the class, I would say like that 90% represents the students that pass. So in this case, that 20% represents the tip, right? So it's a 20% tip. So we're going to say percent tip here. And what that tells me is that the amount has to tell me the dollar amount of the tip. So the amount is the amount of the tip. Those two words are always the same. Whatever the percent represents, and I always start with the percent because it's the easiest thing to find in the problem, right? Only one number is going to have a percent on it. So once I write a word for what the percent represents, the amount has to represent exactly the same thing. If you find yourself writing two different words there, numerically it's not going to work out because you haven't related the amount and the percent correctly. So far, so good? And then our base, in this case, is going to be the price before the tip. So we have sort of two general types of percent problems. One of them is like you're taking a percent of the whole. So like when we say 90% of the class passes, that 90%, the people that pass are like, that's a part of the whole class, right? Whereas in a situation like this, that tip isn't like an amount we're taking out of the price, right? We're starting with the price and adding on the tip. So we're actually increasing the price. Whereas when I talk about 90% of students passing, we're not increasing the number of students in the class. right, when we say that. So sometimes it's a change, and sometimes it's just part of a whole. In this situation, the price is actually changing when I add on the tip. In that case, the base is always before the change, whether you know it or not. So it's tempting sometimes to just put whatever number they give you there, but that base always has to be before the change. Before starts with B, as does base, which is helpful in remembering that. So my percent tip is 20%. What is the amount of my tip? $9. And what is the price before the tip? $45. Good. And we can verify that, in fact, A does equal P times B. So 9 equals 0.2 times 45. And we did that one just with numbers, just so we could get the hang of how to set it up. We'll throw some variables in here in a minute. Does that make sense? Okay. Let's look at number 4. So it says if 80 milliliters of an acid solution contains 16 milliliters of acid, I want to know the concentration of the acid in the solution. So again, we're going to start exactly the same way. We have amount, percent, base. What does my percent represent here?
The concentration of acid.
The concentration of acid, good. So it's the percent of acid, which means that the amount has to represent the amount of that solution that's acid. Like if I could separate the acid from the rest of the solution, however many milliliters that would be, that's pure acid, is what my amount is. So the amount of acid. And then what does my base represent here?
Solution.
Yeah, the total amount of solution I have, right? So the milliliters of solution. Do we know our percent? So that's going to be X. Do we know our base?
80 milliliters.
Yep, we have 80 milliliters of solution. And do we know the amount of acid? 16 milliliters. Good. Once you've done this, again, we use the same equation every time, that A equals percent, or P times B. So amount equals percent times base. My amount is 16. I don't know my percent. My base is 80. Divide both sides by 80, we get X equals 0.2. So the solution is 20% acid. How's this sitting with you? Good? I know if you took 065, this is probably quite a bit of review. But we just want to make sure everybody's on the same page. Good stuff? Okay, let's do... Oh, we can do this one. Okay, so we want to create a bag of mixed nuts that is 30% peanuts. And we're filling the bag, and I have 2.5 pounds of peanuts to use. And I want to know what the weight of the bag will be once I've mixed all my nuts together. So again, APB. The reason I know, like, if this was a test or something that had a mixture of different types of problems, I know to do the APB setup because this problem contains a percentage. As opposed to the problems that we did yesterday, there weren't any percentages there, so we don't use this setup. So you want to ask yourself which type of problem it is before you start setting things up. What does my percent represent here?
Peanuts.
Peanuts. Which means that the amount has to be the amount of peanuts in my mixture. What's my base represent?
Mixture.
Yeah, it's like the total pounds of mixed nuts that I have, right? So pounds of mixed nuts. And I try to be fairly specific here. I'm not like super picky about like how you write these things, but it should be clear, like the differentiation between peanuts and like the mixed nuts, right? Like if you were just like amount nuts, percent nuts, base pounds of nuts, like that's true. All of these are measuring nuts, but it doesn't help you distinguish between which is which. So try to be specific enough that you can look back and be like, oh, this is what the amount is. Do I know the percent peanuts?
Yes.
We do. It is 30%. Do I know the number of pounds of mixed nuts that I have? I don't, right? So that's going to be my variable. And then do I know the amount of peanuts? It is 2.5. Another way to check that you've put everything in the right place is that these two guys always have the same units. The amount is measured in pounds, and the total is also measured in pounds. So we have A equals P times B, which means 2.5 equals 0.3 times X. So X equals, oh, that's an annoying number, but what is it? It's like 8.3. We'll just round it to 8.3, yeah. So 8.3 pounds of mixed nuts. As far as rounding goes, on the test, we typically tell you like to round to one digit, just so you don't have to wonder. But in general, just do what seems reasonable to you. On my math lab, underneath the answer blank, there's often like navy words in parentheses, and they tell you things like what if your answer should be a decimal or a percent, or sorry, a decimal or a fraction, what you should round to if you're gonna round. So always read that line under the answer blank, because there's nothing more frustrating than doing a problem right and then entering it and having it come up as wrong because like you rounded to 3 digits instead of 2 or something silly like that. So always read that a little bit. Questions on this one? We're doing good? Okay. We are going to skip to 7. Okay, so we'll start with the same setup. We have amount, percent, base, and go ahead and solve this, set this one up and solve it. And I'll come around and help you as needed. Which means that our amount also has to represent the tax. And what's our base? Or what does it represent, rather?
Cost of the coat.
Yep, so the cost of the coat, is it the total cost of the coat? It's the cost of the coat before the tax, right? This is one of those situations where we're adding or taking away something. And so the base is the cost before tax. Do we know the percent tax? It's 4%. Do we know the cost of the coat before the tax? Do we? Yep, 75, good. And do we know the amount of the tax? We don't, so that's our variable. So X equals 0.04 times 75, which gives me X equals, 3? What did I just find? Yeah, I found what the sales tax is, right? What do I want? The total. So I have to add that sales tax on, right? Because you still have to pay for the coat. So the total cost is $78. So that's another thing to be careful of is a lot of times in these problems, like X isn't going to be like, isn't always going to be what they're asking you for in the question. So X is always going to be either the amount, the percent, or the base. And sometimes they ask for like some final value that isn't even represented in that setup. But we use the same setup in the same equation, and then we just have like one more step to go from there. Okay, so let's go the other way around. So this problem is a little tricky because there's a lot going on. I'm going to cross this out first so that we can do this for a single percentage. And then we'll jump back in and see what it would look like when we actually apply the sales tax as well, just so we don't have to start with two of them. One thing to keep in mind about percentages is that they don't add. So like if I do a discount and then apply a sales tax, the base price when I take the discount is different than the price I'm applying the sales tax to, right? Because I apply the sales tax after the discount. So I can't just like add them together or subtract them to get a single percentage. We actually have to do it in steps. So that's why I'm getting rid of the sales tax first. We'll do it just with the discount, and then we'll do a second step where we apply the sales tax. So we're told that when we buy two of the same kind of shirt at 35% off, after 6% sales tax, that we're charged $68.90. And we want to know the original price of one shirt. Any idea of one thing we could do at the very beginning that might simplify this a bit?
Divide 68.90 by 2.
Yeah, so they give us how much we pay for two shirts. They ask us the original price of just one shirt. So the first thing we're going to do is just cut that in half so that all we're talking about is one shirt. Like, we don't need to talk about two shirts the whole time, right? So the price of one shirt after discount and sales tax is what, $34.45. So just in terms of like the order we're going to do stuff in, I kind of already gave it away because I crossed off one of them. But does it make sense to you guys that we would take the discount first and then apply the sales tax? Right? Because it would be kind of a ripoff if they charge you sales tax on the original price and then took a discount off that, right? They only apply a sales tax to the actual amount that you're paying. So we would take the discount first and then apply the sales tax to that. So that's why we're ignoring the sales tax for a minute and just working with the discount, because that's the first step in this process of buying this shirt, or two shirts. So we have A, P, and B. What does my percent represent here? So remember, we're doing the discount first. So yeah, just the discount. And like, we're really just ignoring the sales tax at this point. And then, so what does the amount represent?
Discount.
The discount. So the percent is the percent of the discount. The amount is going to be the dollar amount of our discount. So the amount of our discount. And what's our base going to be? What's that represent?
Total cost of one shirt.
Uh-huh. So the total before or after the discount? Before. Very good. So the price before the discount. So this problem is different from the problems we've done so far in that we actually have two unknowns instead of one, right? The only thing we're given here as far as the amount, the percent, and the base is the discount. we know the discount is 35%, but we don't know the price before the discount, and we don't know the amount of the discount. So that begs the question, like, what should our variable be? When you're in a situation like this, and you may have noticed that when I went through this, I always did the percent first, and then I asked if we knew the base, and then went back up to the amount. And the reason I do that is because if the base is unknown, that will be your variable, regardless of whether or not you know the amount. So in general, if you have two unknowns, amount and base, the base is always going to be your variable. So we're going to make the price before the discount X. And the reason that we do that is that just like we did yesterday when we had like that length and width problem, they told us what the width was in terms of the length, right? So we could write an expression for the width. Same thing here, we know the amount is equal to the percent times the base. So if the percent is 35% and the base is X, then I know the amount of my discount is 0.35X. Very loud vibrating. I'm sorry. It's awful. So now we have, well, we can't just write an A equals P times B equation and solve it, right? Because shucks, that's always true, right? That doesn't give me an equation I can solve and figure out what X is. So we have to think in terms of that number and how it relates to the rest of this. So I want you to just think about going shopping. So forget about the math, forget about if we're dividing or adding or multiplying or what have you. If you went shopping and something cost like $100 and it was 15% off, how would you find the sale price? Okay. So you would multiply the discount, the percent discount, by the original price, yeah? So in this case, that's 0.35x. Is that the sales tax? Or sorry, the sales price? Yes.
Couldn't you take that away from 1 and multiply the number times that to get the price?
Yep. Yes, that's exactly right. So your original price, you have 100% of your original price to begin with, right? You always start with 100%. If you have a discount of 35%, then what percent do you actually pay for? 65%. 65%. So your sale price is 65% times your original price. If doing that in your head isn't super clear, you can also think of it as, to find my sale price, I start with my original price, which is X, and then I subtract my discount. So X minus 0.35X, and you'll notice that 1X minus 0.35X also gives you 0.65X. So either way you want to set it up is fine, whichever makes the most sense to you. Okay, so now we have to think about our sales tax. So we can't solve this equation yet because we don't know the sale price, right? We know the price after the tax, but we don't know the price just after the discount. So let's give it a variable. Let's call it S, just so we don't have to keep writing sale price every time. And we are going to repeat this entire process for the application of the sales tax. So we have A, we have P, and we have B. What does our percent represent now? 6% is the tax, yep. So we have the percent tax. That means the amount is the dollar amount of the tax. What's our base here? What's it represent?
Cost before the tax.
Yeah, it's the cost before the tax, which is what we call the sale price here, right? Because we're not taking 6% of the original price to apply the sales tax. We're taking 6% of whatever we got after the discount. And so this is going to be the sale price. So this is like the price after discount before tax. So the percent tax is 6%. Do I know the sale price after the discount but before the tax? I don't, right? But up here we called it S. Do we know the amount of the tax?
No.
We don't. So just like we did in the one above, we're going to use the fact that the amount is equal to the percent times the base and say the amount of my tax is 0.06 times S. Whoa. We're running out of room. Just jump on down. Okay, so time to write an equation. Again, we can't just relate these three things because we don't have enough information to actually solve for S there, right? There's not another number. So we have to go back to this. So we have to go back to the price after all of this happens. So my final price after the discount and the sales tax, how would we find that? And just think of it in terms of the tax, because we've already broken this down so that we've assumed that that discount already happened, right? So how would we find the final price after tax? Think about what you have to pay for. Do you have to pay for the shirt? So we have to pay this S dollars no matter what, don't we? And then on top of that, we have to pay what? Tax. So we also have to pay 0.06 S. Make sense? Mm-hmm. So my final price is 1.06 S, because that's a 1. And again, we can think of it sort of the same way we got that 0.65. Like, if I have to pay for my shirt, we always start with 100%. So I have to pay 100% of the price for my shirt, and then 6% on top of that, my total cost, my final price, is going to be 106% of the sales price, right? After tax. So we have that 1.06. Do we know our final price? What's that go? Do we know it? Mm-hmm. It is 68.9, right? And we have 1.06, but we don't want S, we want X. So we're going to replace S with 0.65X. We got that from here. So we sort of worked our way up to the final price, and now we're just going to plug in so that we can have it in terms of X again. And then we'll solve that for X. I'm not sure what it is, but what's 1.06 times 0.65? 0.689. Oh, that works out really nicely, doesn't it? So X equals $100.
That is not the price for 2 shirts.
No, oh, I'm so sorry. You're right. Thank you. I'm trying to rush here, and it's messing me all up. Huh? So this is 50. The good news is that the problem on your homework that's like this only has one step to it. There's not, you don't have to apply two different percentages. So it's going to be more like just the first piece of that. But you can still use this as a guide as far as how to set it up. We wanted to show you both the up and the down, right? Taking off and adding on. So tonight, you don't have these. Don't worry about that right now. So you have no My Math Lab, but you do have written work in the form of a worksheet. And I wanted to mention also about the My Math Lab that if you run out of chances, so if you do, like, answer it 3 times and it's wrong, and then you answer it 3 more times, or you get the similar problem and you answer it 3 more times and it's wrong again, you can always come to my office or email me for additional tries. We limit them just so you don't do it wrong like 500 times and then like happen upon the right answer once, because you're going to remember what you do most. So when you run out of tries, that's just the clue that you should get some help with it. But you can always get 100% of your My Math Lab by asking for more tries and going back and fixing them. And you can fix them after the due date. So if there's a couple problems like that are incorrect, you can always go back in and fix them up until test day. So that one that was due yesterday, if it's not 100%, you can still go back in and bring it up. Okay, sorry I kept you a couple minutes late. I will see you Monday. Have a great weekend. Hi.
Hi. Sorry that I'm 2 days late.
That's okay. I haven't read this email, so I don't
Yeah, she just
know what exactly is going on.